All right, number 47. Is that the right one? Okay. Because this is log base 5 and this is a 5, that means they kind of undo each other. X falls down. Done. Anything else you want me to go over from the homework? Yeah. 63. Okay. So on that one, I have a base of 3 halves. So I kind of have to think, can I make my 27 over 8 be 3 halves raised to an exponent? And I think I could. I think I could say that, I think I could say 27 is 3 to the third, 8 is 2 to the third. So I have that. Now these are the same. So they cancel out, so your exponent just comes down, and 3 is your answer. Yeah. 59. Natural log of 0. Did anyone try that on a calculator, see what it comes out to? So let's just verify on a calculator. Natural log of 0 becomes an error. Okay, so here's the thing. Log and natural log of 0 or negative numbers does not exist. Okay? Does that make sense? So that means our domain is going to be restricted on log and natural log. Our domain will be restricted from soft bracket 0 to infinity, meaning it could be a small decimal. It can't be 0, so that's why it's an open bracket. So we didn't ask for this, but the domain of this is this. And it's the same for log. Yeah. 67. I get log. Oh, no, I take it back. I'm making stuff up. I get 10 raised to log 49. Okay. So if you see log by itself, that defaults to it being log 10. Being that takes place, those cancel out. Our 49 just comes out and just becomes our answer. Okay. Anything else? Everything else good? Going once, going twice, sold. Will you get your notes out that I had given you in that packet and get to H. H, I believe, is what I'm on. Unless I'm losing my mind, which is very possible. Someone says, we're still on chapter 3. Uh-oh. All right. So rules and properties of logarithms, I think you're going to find this is a breath of fresh air once you see how to do it. It's not a tough concept. And the nice thing is the rules for log and natural log are the same rules, which is great. Okay? So moving on. All right, what properties do we use to simplify exponents? Well, if I'm multiplying two like bases together, the exponents add together. So that would give me x to the 12th. If I had the same bases as a fraction, I refer to it as tug of war. It's the top subtract the bottom. So you subtract them. So that gives me x to the 5th. If I did tug of war, who wins, top or bottom? You say top. By how many? 5. Done. And then power to a power means that I multiply the exponents, so I get x to the 10th. Okay? So that kind of is some review. Any questions? All right. What connections can you make between logarithms and exponents? Okay, so if log just sits by itself and it doesn't have a base, it automatically defaults to base what? 10. So there's automatically a base 10 right there. So then we have to think about 1,000. Well, 10 to the second is 100. 10 to the third is 1,000. So this converts to log base 10 of 10 to the third. Because these are the same, the exponent just drops, and you just get an answer of 3. If I have log base 32 or log base 2 of 32, we have to think, can I make 32 become base 2 by making an exponent? Well, 32 is 2, 4, 8, 16, 32. It's 2 to the 5th power. So log base 2 of 2 to the 5th, those drop out because they were the same. Exponent falls down, and we just get an answer of 5. So what connection between logarithms and exponents? Well, a logarithm is mainly dealing with the exponent. Okay, and we could do the seashell thing to convert it as long as the log's on the same side. But I'm also going to show you how to convert back from an exponent to a logarithm. Okay, so log base 10, so I know that's base 10, so that's going to give me 1. This is going to give me a negative 1 because that would have become 1. 0.1 is 1 over 10. So if I move the 10 up, I get 10 to the negative 1. They cancel out. This one, I have to remember that 4 is the same thing as 2 squared. So log base 2 of 2 squared just gives me an answer of 2 because those would cancel out. Log of 100 is 10 squared, so that's 2. Log of 0.01 is negative 2. Log, well, I have to realize 8 is 2 to the third. So those now cancel, so I just get 3. And then log of 1,000 is 3 because that's 10 to the third. Log of 0.01 is 1 over 1,000, which is 1 over 10 to the third. 1 over 10 to the third of the 10 moves up, becomes 10 to the negative 3, so that's negative 3. And 32 is 2 to the 5th. So those cancel, so exponent drops down, so it just gives me 5. So can we make a conjecture of how to find the log of a product u and v? I don't know. Well, we're going to figure this out. So I think we're going to start expanding these. And the rules of expansion are pretty straightforward. Okay, how can we write 125 as a power? Well, it can be 5 to the third. How can I write it as a product? It's 5 times 5 times 5. Okay, so our conjecture for log of a product is, I don't know yet. Or we could realize that we maybe just put this as the same thing as 5 times 5 times 5. Okay, so we might be able to say that. But I think we're going to come up with a little bit better rule that's going to harness us in. Okay. Let's reduce the fraction first. 1,000 over 100 is? Just going to come out to 10. So what is the log of 10? 1. Okay. Especially because log as it sits as itself is log base 10. What is 10,000 over 100? It gives me 100. 100 is the same thing as 10 squared. Log as itself is log base 10. Those cancel, so that gives me 2, like you just said. Good. And then 10,000 over 1,000. Cross off 3 of those. That becomes log of 10, which is equal to 1. Am I going too fast for anybody? Starting to see the fun stuff that goes with these? All right. So here are some properties. The product property, they're just saying log base b. Doesn't matter what base b is. If I'm multiplying two terms together, like I could take 10 and make 10 2 times 5. Agree? So when you are multiplying things together, you keep the log base, whatever it was, and you just add them. If you're dividing it, notice there's a negative sign. And if you have an exponent, the exponent can come down right out front. So it drops the exponents down. Okay? And we're going to focus on these rules in a moment, and they tell us that b is not going to be equal. We're not going to have log base 1. Okay? All right. So let's keep that in mind. First thing I want to do is I'm going to convert 8 and I'm going to convert 16 into base 2. So 8 is 2 to the third. Agree? 2 times 2 times 2. And 16 is 2 times 2 times 2 times 2, so 2 to the fourth. So let's do this real quick. Log base 2. And I have 2 to the third, 2 to the fourth. Like bases, I can add the exponents. Those cancel. Exponent drops down, so I just wind up with an answer of 7 for that one. Number 2, I have log base 2 of an 8, and 8 happens to be raised to the third power. Well, let's not worry about 8 to the third right now. Let's change 8 to base 2. 8 is the same thing as 2 to the third. So this becomes log base 2 of 2 to the third. Power to power, I multiply the exponents, so I get 2 to the 9th. Those cancel. Winds up with just 9 for an answer. Natural log and e are the same thing. Natural log and e they're actually inverse operators of each other. So these just cancel each other out, so I just wind up with an answer of -4. Okay, now notice I can get a negative answer, but I can't do the log or the natural log of a negative number. But my answer can be negative. That just means that the fraction would have been flipped over. On this particular one, I have log base 3. So I'm going to expand this first. Okay, notice I have a subtraction sign there. The subtraction sign, if you see a subtraction sign prior to log or natural log, that means that it would have been a denominator originally. Is that okay? So what is the log of 1 if I didn't have a log base 3 there? What's log of 1? 0. So log base whatever of 1 is 0. So this gives me a 0. Minus, hey, what does 27 break down to so I can get it as base 3? 3 to the third. So that's the same thing as 3 to the third. So log base 3 of 3 to the third, those cancel. So I get 0, subtract 3, so I get -3 for an answer. Yeah?
Did we just have done 10 to 1 over 27 and 3 to the -3?
Perfect. And that totally would have worked. Yeah, we could have turned 1 over 27 into 3 to the -3rd. It could have been 1 over 3 to the third. Move the 3 to the third up so the sign becomes negative. So I get 3 to the -3. 3 to the -3. Log base 3 of 3 to the -3 is -3, so answer still works. Oops, come on. Let's do this one like you just said. Same idea. ln e to the -5. Where did the 1 go? Well, it's a denominator now. Something over 1 is something. All right, natural log of e. Do they cancel? They're inverse operations. They cancel. So those are gone. So I just get -5 for an answer. And we're done. And then this one, I have 0.001 to the fifth. Now, I wouldn't say go plug 0.001 to the fifth into your calculator. Let's focus on 0.001. 0.001 is 1 over 1,000. Agree? 1,000 is 10 to the third. Agree? If I move 10 to the third up, what happens to the 3? becomes negative. So I get 10 to the negative 3. So now I can plug 10 to the negative 3 back in for this. So I get log of 10 to the negative 3 raised to the 5th. Power to a power, the exponents do what? Multiply. So negative 3 times 5 is negative 15. Log as itself is always log base 10, so those cancel. So I wind up with an answer of just negative 15. Am I going too fast, or are we okay? Seem to be okay. May I move on? All right. So now we want to expand. All right. Let's convert 8 to, what's the smallest base to an exponent for 8? 2 to the third. Now, it doesn't really help me with canceling anything out, but I'm going to get that. But now I want to expand it. I want to expand it. So this is going to become log base 3 of 2 to the third plus log base 3 of x. What does the exponent do? It's not going to cancel out, but what can I do with the exponent with a log in front of it? Can it come straight down? It's going to come right to here. So this becomes 3 log base 3 of 2 plus log base 3 of x. And that one was kind of silly because I don't know if they wanted just right away to convert 8 to 2 to the third. But number 12 is a little simpler. These are all being multiplied together, agreed? So this is going to become log A plus log B plus log C. Being everything's positive means that I would have multiplied those all together to put it back together. Okay? Hey, friends, number 13. Is 6 the same thing as 2 times 3? And what I'm trying to show you is we can break numbers down to their prime components, which is kind of where we're trying to head with these. So I get ln 5 over 2 times 3. Is that okay so far? We have a fraction. That means anything in the denominator, when I expand it, will have a negative sign in front of it. Okay? Anything in the denominator will have a negative sign in front of it when I expand it. So I have ln 5 minus ln 2 minus ln 3. The minus ln 2 and the minus ln 3 means that the 2 and 3 would have been a denominator originally. The natural log of 5 means it would have been a numerator. Does that make sense? So if you can break it down, break it down. Break your number down to its prime components. Anyone want to take a shot at what number 14 is going to be? ln and x don't cancel each other out, do they? X has an exponent of 3, so the 3 can come down front. So this becomes 3 ln x. A number preceding a log or a natural log means you can move it back up to be an exponent. Okay? There's some stuff that's taking place with these. 4 more slides to go. Can we make it? I think so. Want to teach for us? Sure. Come on. Come on, don't be stuck up. I'm just kidding. I'm giving you a hard time. All right. Here we go. So we're going to keep in mind, if we have an exponent, that exponent can come down in front of our log. Got it? If things are being multiplied together, they will be positive when I expand it. Agree? So I get log base 3 of 5, because 5 is a prime number, it's not going to break down, plus 2 log x, because that was x squared, so the exponent can come down front, plus 3 log y. So again, the number preceding the log or the natural log means it could have been an exponent originally. The exponents moved down. For number 16, I think we should convert 25 to 5 squared. Okay. So this is going to be exponents can come down front. Agree? All right. Log base 5. I'm bringing 3 out front. Plus, I made a mistake. Minus log 2. Try and squeeze things in. Things just get bad. Minus 2 log base 5 of 5. This one is almost done. Does anybody see something that's going to change? Yeah. Yeah, the log base 5 of 5, they cancel each other out. So this would have canceled here. So I would get 3 log base 5 of x minus 2, because the log base 5 of 5 would cancel out. Ooh. A square root (720 277 2176). Stirrups mortuary, you stab them, we slab them. I shouldn't have a phone. I really should. I get bored. If I got a live person on the line and I know it's a scam, I will keep, especially during summer, like I'm working in the garden, phone rings, I'll keep the guy on the line for an hour. It's like, hello? Hey, my dad? Oh, no, I'm not your dad. No, it's my dad. And you just start getting weird on him. I don't know. There's something wrong with me. Y'all figured that out already, I think. Hey, root x is what as an exponent? 1/2. So I'm not going to expand this yet. I'm just going to make us realize that this is the same thing. Is that okay? Exponents can come out down front of when we expand it. So I'm going to get log base 3 of 5 plus or minus. Plus, because I'm multiplying it, right? Plus log base 3. Ooh, forgot the 1/2 of log base 3 of 5. So log base 3 of 5. Oh, I tell you, I can't. I'm sitting there thinking about phone calls. I'm sorry. So the 1/2 on the x can come down front. So notice there's not a 1/2 in front of the log base 3 of 5 because that wasn't raised to a power. So I expand it. So log base 3 of 5 plus the 1/2 comes down on the x, 1/2 log base 3 of x. Done. Hey, friends, the third root would be what is an exponent? 1/3. Oh, you guys are so smart. Log base 7 of x, the 1/3 over 7. The 1/3 is going to come down in front of log for x. Agree? The 7 is going to be what kind of sign? Minus, because it's a denominator. So I'm going to get 1/3 log base 7 of x minus log base 7 of 7. What's log base 7 of 7? They cancel out. So technically there was a 1 right here, right? So it's 1. So then I get 1/3 log base 7 of x minus 1. Because the log base 7 of 7 cancel out. And any number can be raised to an exponent of 1. Okay. 2 slides left. Best day ever, man. We're going to have time. We're going to go get ice cream. I love it. So if we can expand, my friends, we can condense. Okay? If we condense, we put it back under 1 log or 1 natural log. All right. So I'm going to condense the following. These are all positive, so that means they would have been multiplied together. So I just get log 5c. And if log sits by itself, that means it's log base 10. But we don't have to put base 10 because it automatically goes to. Number 20. Which part's going to be denominator? 15. So I'm going to get log base 6 over 15. My friends, can I reduce 6 over 15? I think 3 goes into both. So I'm going to get log base 2 over 5. Done. Oh, that same person called just emailed me. They said the COVID test came back positive. I'm kidding. I'm just kidding. I'm sorry. I have a bad sense of humor. I can't laugh at that stuff. Natural log 28 over 7. Make sense? 28 over 7 reduces to what? Extra credit on this one. 2 ln 2. Wait, where did that just come from? Well, 4 is 2 squared. The exponent can come down front. If you can start breaking numbers down to their prime components, I can assure you later math classes are going to be primo. You'll be like, yeehaw. You look like the rhinestone cowboy and cowgirl in there. Let's see. Hey, what happens to the 3 in front of the log base 3? It becomes an exponent. And these are being added together originally, so that means I'm multiplying them. I don't have any denominators. So I'm going to get log base 3 of 6 x to the third, and it's done. Now someone might ask, should I break 6 down to 2 and 3? I guess you could. I wouldn't because you're condensing it, so you're putting it back together. If you expand it, maybe you could go with that. But being you're condensing it, you're trying to put it back to its normal terms. Does that make sense? Okay. We need to feel real fortunate that we have logs and natural logs. And I know it doesn't make sense right now, but there's something that's happening that you all will get to see. Hopefully I'll get to see in my lifetime. Hopefully I'm around for a few more years. But we're putting people on Mars eventually. Agreed? Agreed? We've heard of this. This isn't like some news like, hey, what's this nonsense you speak of? And 20 years ago, that was nonsense. But the programming and the math that are used, they want to keep numbers as logs and natural logs. They don't want to have decimal approximates. A decimal approximate has a margin of error, which doesn't seem like much here. But basically, when we take that rocket ship and we put it 22 miles up in an orbit, and it becomes on an orbit where it's going faster than the rotation of the Earth, so it gets further and further out in the orbit, and eventually it breaks Earth's orbit, and Earth's orbit acts like a slingshot to go towards where Mars will be. You got to think about that. Where Mars will be. If Mars is right here in the sky, 3 months from now, Mars isn't right there in our sky. Mars is moving. Earth is moving. So we got to make sure we know where Mars will be. Because if we launch it right directly towards Mars, it's going to take us 3 months to get there. And basically, think of this. You've all thrown a rock or a ball or a snowball at some point, right? Yes, I've thrown oranges. Okay? All right. So, if you were to throw a ball to somebody, and you can throw correctly, you throw in the direction that they are. But if the person is running, if that person's running this way, do you throw directly to where they were or where they will be? Hopefully you try and read where they will be. Maybe they have to speed up the run or slow down the run to get the ball because you miscalculated. Unfortunately, we can't say, hey, Mars, Stop your orbit. Good. We're trying to get you. Okay? This allows exact answers to take place. And again, my friends, because once we launch a rocket to go towards the moon or to Mars or to wherever, we have to know its orbit to where it will be going around the sun and when it would be there. So if we know that it's going to take us 90 days to get someplace, we have to know exactly where Mars would be in 90 days. Okay? Think about it even going further out. Let's say something we could get to in 4 years. We'd have to know where it is in its orbit in 4 years. Because once we release that baseball and throw it, that baseball is going to continue in the direction we threw it. Once that rocket's done breaking the path, the orbit of the planet, it's going to continue in the direction that it was released at. If we say, you know what, 0.25 rounded to one decimal place is fine. But let's say it's supposed to be 2.5, 167, 1673, 277, forever and forever and ever. 2.5 has a huge margin of error. You either got to where the planet should be way early, or the planet has now passed you by in its orbit, and you're continuing on that direction, and that planet's over there, and you're like, nothing we can do. Yes, we do have a couple of little things on board that will allow us to try and correct course, but our main rockets, because of Elon Musk and how cool his stuff is, those rockets already landed back on the planet. They didn't just fall back to the planet with parachutes and crash in the ocean, and then they say, hey, the salt water did really bad stuff to our tank, so we can't reuse it. They developed a way to reuse it. So we have subtle things that can try and make little corrections, and once you make an error, it's better that you make your correction early than late. The late correction means an awful lot has to be done to make that spacecraft go. And I'm pretty excited for us to go to Mars. The reason I'm excited for it is because when we sent somebody to the moon, they had to develop a new technology. We had to develop a technology that allowed us to communicate with something that's in outer space, far away. So because the 1960s, with the space race, into the 1970s, when we continued to put people on the moon, there's something y'all have, and I have because I shouldn't have, but I have. But our cell phone capabilities are the technology that was developed for us to have cell phones now. If we didn't put people on the moon, we'd still be attached to the wall with phones. Think about that. So what technology will be developed for us to go to Mars, which is much further than the moon? The moon's only a 3-day flight. Mars is a lot further. There's going to be better technology developed. Those scientists and those engineers and those technicians are really smart people. And they're going to say, wow, we figured out how to send a message faster than the speed of light, so we didn't have any lag time in our message. Now think about what this means. Oh, this is scary. Do you know what happens if something travels faster than the speed of light? That means you're thinking about sending your friend a message, and your friend already got the message you were just thinking about. You didn't even type it in yet. Oh, wait a minute. I don't know if that's too good. So you mean to say that my thoughts could show up on somebody's phone before I even type something? Boy, I'm glad I'm not a little kid anymore, because some of the things I said to my mom after she left the room, oh boy, whew, you know. I was like, no, Mom, I want pancakes. Those things I would say. I'm just kidding. I'm sure there was much worse things I had said. I'm sure my daughters have said things to me as I left the room. That's why one goes to school in Nebraska and the other one is now looking at Penn State as their number one. Get away from this guy. All right, let's do our last slide. Guys, what's Strupp do today? I went off on a tangent, talked about going to outer space. I don't know what the hell he's talking about. You guys walk out of class shaking your heads. All right. Use the properties of logs to evaluate each expression. Oh. Okay. 8 to the 1/3 power, what do you think that would be? 2? 8 to the 1/3 is 2? So I'm okay with this so far. You agree? I could put those back together. 2 times 200 is? Ooh. Okay. Any thoughts? How can we get further on this? What's that? 4 times 100? You guys are so smart. Which is technically log 4 plus 2. Wait. Where? If I expanded that, that should have been log 4 plus log 100. Where did the 2 come from? Well, 100 is 10 squared, right? 10 squared is log base 10 squared is 2. You got a better way? So if I expand it right here, log 100 is 10 squared, which comes out to 2. So I guess I could have this as well. I could have this as an answer, and this is fine. So that or that. Are you talking right here? Right. Where are you talking? On here? So that's log 400, which is 4 times 100. And the reason I went to 100 was I know that I can make 110 squared. And being I have just regular log, I think we can do that. Did I answer your question? No, you didn't. And I'm telling my mom. Oh, sorry. I'm just kidding. Thoughts on letter B? If I put it back together, what am I going to get as a reduced thing? I get 50 over 2. 50 over 2 is 25. So this becomes log base 5 of 25. And I learned because, you had much better teachers than me in your past. You know that 25 is 5 squared. Log base 5 of 5 goes away. The answer becomes 2. Done. Hey, you guys want a lot of homework tonight? Oh, come on. What do you say we do 9H? Let's do this. 9H odds or 20 honest minutes outside of class. So if you could tell me tomorrow, I was working on this, I wanted to get all the odds done, but I put 20 honest minutes in outside of class, and I didn't quite get done, that's good enough for me. Is that a deal? Hopefully that takes a little off your plate. I know some of the teachers are like, hey, here's 16 hours worth of homework due tomorrow. Here's the summation of everything you missed because we were only doing 60% speed for 9 months of the school year. Right? I'm trying not to be that guy. Does that make sense? Everyone understand that? So if you come to me tomorrow and say, hey, I put 20 honest minutes in, 20 honest minutes hopefully isn't just your name at the top of the paper. If so, you might have a problem or two. But friends, get out of here. Have a great day. Take care of one another.